All right, now we're going to look at 8-53. So again, we want to do our x and y given because this will help us. So before I read the problem, I'm going to write ax is 0 and g is equal to negative 9.8. So number 53 says a projectile is launched at an angle of 40 degrees above the horizontal and the initial velocity is 60. So I'm going to draw my picture. Here's my velocity. This is 60 meters per second. This is v naught, and this angle here is 30 degrees. It lands 50 meters higher than the initial launch position. So what's going to happen is there's like a building or something, and it's going to go like this. I didn't draw that good, but so what I know is this is going to be 50 meters. Oh, okay, this is 40. Okay, thank you. So this was 50 meters. I was looking at the problem before that said 30. It's hard to go back and forth. All right, thank you. So determine the maximum height. So there's a lot of stuff we want to find here. So first of all, the first thing I always want to do is I'm going to take my initial velocity, which is 60, and I'm going to break it up into its horizontal and vertical component. So this is going to be v naught x, and from the head of that vector, I'm going to do the tail of the other, which is v naught y, and this is 40 degrees. All right. So v naught x is equal to v naught cosine of theta. So when I do that on my calculator, v naught x is equal to 60 times the cosine of 40. 60 times the cosine of 40. Okay, so 40 cosine times 60 should be 45.96. So we'll say v naught x is equal to 46. V naught y is equal to v naught sine of theta. So v naught y is equal to 60 times sine of 40. And then when we do that, that comes out to be 38.56. So we'll say v naught y is equal to 38.6. Now I'm going to put these in my given. V naught x is 46, and v naught y is 38.6. Now, they don't give me the time. They don't give me how far it goes. Okay? So we have to figure out. So for this part, the maximum height is at the very top of the path. So when we're looking at a projectile like this, here's my initial velocity. It's going to go like this, but at this point right here, this is my maximum height. At the maximum height, the vertical component of the velocity is 0. Because this initial velocity, we know the horizontal part is constant, but the vertical part, because gravity's pulling down, is going to decrease, decrease, decrease. So as this height here, we know that Vy, we'll call it Vfy, is 0, only at that point. So now I know for part A, when it said find the maximum height is y, all right? But I know at this maximum height, I know another variable that Vfy is equal to 0. So now I know Vfy, I know v naught y, I know g, and I want to find y. So now I'm going to say to myself, which equation has those 4 variables? So I'm going to use the equation Vfy squared is equal to v naught y squared plus 2gy. So now I can rearrange the equation and say Vfy squared minus v naught y squared over 2g is equal to y. So that's going to be Vfy is 0. So it's going to be negative 38.6 squared divided by 2 times negative 9.8. And you see the negative in the numerator cancels with the negative in the denominator. So I get a positive value for y, because see how y is positive, it goes up. So I need to be consistent with my sign convention. So 38.6 divided by. So I end up getting that y is equal to 76 meters. Okay, now let's look at B. Part B says determine the total time of the flight to impact. Now this is not what I found in Part B, because what I'm finding now in Part B is going to be to here. Does everyone see that? Okay, it's going to be to here. So this is like completely different than what I did before. Okay. So anyway, this part might have more than one step, because if I look at the variables and I want to find the time, if I look at my equations that have the time, I have the equation y is equal to v naught yt plus 1/2 gt squared. And this is the quadratic. And I also have the equation vf y is equal to v naught y plus gt. The problem is I don't know this VFY up here, do I? I don't know that. There's more than one way to do this problem. So there's, again, when we do projectiles, there's more than one way. So the way I'm going to do it right now is I'm going to say that VFY squared is equal to V naught y squared plus 2GY. And now I'm going to rearrange this equation to find VFY. So VFY is equal to the square root of V naught y squared plus 2GY. So that's equal to the square root of 38.6 squared plus 2 times negative 9.8 times 50. Okay. So now when I do this, let me put up my calculator. 50 times 9.8. So when I do that, VFY comes out to be, now remember, when I take a square root can be what? A positive or negative value, right? So this, it's coming back down. So this, because we already know this is at the maximum height. So this is going to be the negative one. It's going to be negative 22.5 meters per second. Now I can go ahead and take this and substitute it in this equation to solve for t. So VF is equal to V naught plus GT. So VF minus V naught over G is equal to T. Now this is where you have to be very careful with your signs. So VF is negative 22.5 meters per second minus V naught. V naught y is, oops, I need to do my subscripts, minus 38.6 meters per second divided by negative 9.8 meters per second squared. So I forgot the 0.5 here. So 22.5 negative minus 38.6. So this comes out to be 6.23 seconds. The negatives cancel, and a meter per second divided by a meter per second squared is when we work it all out, it comes out to be a second. Part C, it says determine the range on impact. So x is equal to v naught xt. So it's equal to 46 meters per second times the time I just found, 6.23. I think that was actually 6.24. I'm looking at my calculator, and I think this is 6.24. I didn't look at the last digit and round. So 6.24 times, so that comes about to be 287 meters. And I'm rushing because we have a second before the bell rings. In part D, determine the final landing speed. Now the final landing speed looks like this. This is VF. So VF is actually going to be what? It's going to be VFY and VX. So VF is going to be the square root of VFX squared plus VFY squared. So VF is equal to the square root of 46 squared plus negative 22.5 squared. And when I do all that, comes out to be 51.2 meters per second. And that's my final answer. So the more you write down on paper, the less likely you are to make a mistake. And when you're first practicing, sometimes you might not be sure, because a lot of times there's going to be more than one way to find something. So you do it the way that you're most comfortable with.